Assalamu alaikum. So it's a differential equation of first order. Why first order? Because there is no d square v by dt square or higher order. You have only first order here. So in this video we will solve this equation and find a function for v, and we will see that this function looks like a decay function. But wait, we know that we can solve this equation mathematically, but this video will be divided into two parts. At the first part, I will say that by observing this equation or intuitively how to say that this is a decay function. Okay, let's say somehow I decide that this is a decay function. Then the second question is v is decaying linearly or v is decaying like this. Let's say v is some kind of voltage from a circuit. So this voltage is decreasing linearly or decreasing like this. And then another question is will v ever become negative or it will always become positive? So there is a lot of question, and without solving this equation we can say this thing, the behavior of v, by observing this equation. So at the first part we will do these things, and at the second part we will do a simple integration to find the function for v. That means we will solve this linear differential equation and then analyze the solution. Okay, so let's start. So first part, let's observe the equation. Okay, so what was our equation? Tau dy by dt, let's say tau is a constant, plus v is equal to 0, and you will understand what tau is. You will understand it later. Okay, now let's rearrange this equation like this. Then we will find an equation like this. Okay, now let's say that initially, let's say when time was 0, the voltage was, let's say, 5 volt. That means initially the voltage was positive. Okay, now from this equation we can say that dv by dt, from this equation it's clear that dv by dt is negative. And what is dv by dt? Dv by dt is the rate of change of v, and we know that if dv by dt or rate of change of v is negative, if the rate of change is negative, then that thing will decrease. Then it is clear that if the initial voltage is 5 volt, it must be decreased. It must be decreased. So this function will looks like this. So it's a decay function, right? Why it is decay function? Because the rate of change is negative. Now the second question is this a linearly decaying or not? Let's find this problem. Okay, what is dv by dt? What is dv by dt? Yes, dv by dt is rate of change of v, but another thing is it's an v versus, it's a slope. dv by dt is a slope of v versus t graph, right? That means dv by dt is the slope of this graph and also for this graph, because it's also an v versus t graph. Okay, now let's analyze that equation again. dv by dt is equal to minus 1 by tau v. Now let's take a modulus here, and if I take modulus here, then this minus will cancel out. Okay, as v is decreasing, as we know that v is decreasing, that means v is decreasing, the slope is also decreasing, right? And that means we know that for a linear graph the slope must be constant. If this graph is linear, the slope must be constant, but the equation says slope is decreasing. Graph says slope is constant, but the equation says the magnitude of slope is decreasing. That means this graph doesn't represent this equation. Okay, now let's see that will my equation represent this graph? Clearly not, because let's write two graphs here. One looks like this and another looks like this. Okay, now my question is, observing this equation, tell me that which graph represents this equation. Clearly the first graph. Why? Let's understand this. By observing this equation, you will understand that the slope for the first graph is decreasing, right? But for the second graph, the magnitude of slope is increasing. But my equation says that if b is decreasing, the slope, the magnitude of slope must also decrease, and this matches with the first graph. So second graph cannot represent this equation. Okay, so that means we decided two things. One is it's a decay function, and another is the slope is decreasing. And now my third question is, will it always become positive, or it may become negative? Okay, so let me write the equation again. dv by dt is equal to minus 1 by tau v, and analyze this equation at this point. And what is the value of v at this point? Clearly v is equal to 0. And if v is equal to 0, from this equation we can say that dv by dt is equal to 0. And what is dv by dt? The rate of change, right? And as the rate of change at this point is 0, that means voltage cannot be changed at this point. That means the voltage cannot be negative. That means the equation says the voltage cannot be negative, but the graphs is showing me that the voltage is going to negative. That means this graph is not true. And if I analyze this graph, let's take here v is not 0, but v is so small, right? V is so small, so dv by dt, from this equation the magnitude of dv by dt must be small. And analyze here, you will understand that the slope here is so small. Why? Because draw a tangent line here, and you will see that the slope of this tangent is so small, right? That means, so observing this equation, I understand three things. One is it's a decay function. Two, the slope is decreasing. And three, v is always greater than 0. V is always greater than 0 except infinity. Okay, and all this behavior matches with this equation. And so it's intuitively, without solving any math, we understand that this function, this equation equation solution will look like this. Okay, now part 2. Let's do this thing mathematically and let's see our answer is right or wrong. So dv by dt is equal to minus 1 by tau v, right? Now let's take v, this v here, so dv by v, then minus 1 by tau dt. And now let's integrate this thing. Okay, so let's say when time was 0, the voltage was v0, and when time is any random time t, we want to know the voltage. Let's say v is equal to v, and if I integrate the left hand side, I will get ln v, and at the right hand side I will get t. Okay, so now let's put v here, a minus, then ln v0, then t minus 0, So I have a equation look like this. Now take this ln here, we will get e to the power minus t by tau, and now let's v naught here, so v naught e to the power minus t by tau. So this is our equation, and it's a exponentially decay function, right? Let's draw the graph here. V t. So when t is 0, e to the power 0 means 1, e to the power 0 means 1, so v is equal to v naught. That means when time is 0, initial voltage is v naught, and if I write this equation like this, from here we can see that if time increases, voltage will decrease, and when time is infinity, voltage will become v naught divided by infinity, or become 0, right? That means at the infinite time it will become 0, but infinity is practically not possible. That means this graph will always try to touch this time axis, but it can never touch this time axis, and theoretically it will touch at infinite time. Okay, so let's write this graph again. It looks like this, right? Okay, v then t, and the equation of this graph is v naught e to the power minus t by tau. Okay, now let's see one thing, where now one question, when v is equal to b naught by root over 2. Let's find where this is v is equal to b naught by root over 2. So if I put this value here, v naught by root over 2, why I'm doing this you will understand it soon. So let's divide it, and if I take e here, I will get ln okay. Now what? Let me calculate this thing. Actually I was not supposed to do this. Okay, you will find a t from here, but my goal was not this. I want to tell you what is tau actually. Okay, my purpose was not to solve a math. My purpose was what was tau actually. So let's draw this graph again, and draw this write this equation again, and now let's see when t is equal to tau. That means let's say here tau, and let's see what is the voltage when time was tau. Okay, so let's see. So v tau, let's see what will become v tau. So v naught e to the power minus t will be equal to tau, then tau cancels out, so v naught divided by e. So the significance of e is that we can understand that when time is equal to tau, then the voltage is equal to b naught by tau, and if I take calculate 1 by e, then I will get v naught into 0.367 or 36.7%. That means tau is the time when the output voltage will be equal to 36.7% of the initial voltage. Okay, now let's take another thing. Let's say it's v is time, and let's see when the time is 5 tau, what will happen. So v is equal to v naught e to the power minus t by tau. The time is equal to what? 5 tau, right? Okay, so tau cancels out, v naught divided by e to the power 5. It may be a small number. Let's see. Yes, it's a very small number, 6.73 into 10 to the power minus 3. So by convention, when solving any circuit, we assume that when when time is 5 tau, time is equal to 5 tau, the voltage or any function, maybe it current or maybe it is voltage, becomes 0. Okay, that means, okay, what when I will get this graph, let's give a practical example here. When, let's say, the capacitor has initial charge V0 and it is connected with a resistance at time t is equal to 0. So if I draw a graph of the capacitor's voltage, if I draw a graph of capacitor's voltage versus time graph, I will see that initially the voltage is V0, but gradually it will decrease. So when time is equal to tau, output is equal to 36.7% of V0, and when time is equal to 5 tau, the voltage is almost 0. It never becomes 0, but we can say that the voltage is almost 0. That means we can say that the capacitor has been discharged, though can't fully discharge, but we can say it by convention. Okay, so thank you.